Welcome to the Ultralight Airplane Workshop. You found another video covering the design of the ultralight airplane, the UWS-4. And in this design video, we're going to talk about putting in the fuel tank and baggage into our airplane. For those of you who have been following it along at home, you know that we're using Dan Raymer's book, Simplified Aircraft Design for Homebuilders. And this video is covering the last section of Chapter 4. And that section is for sticking in the fuel tank. Now I've added the baggage as a little extra bit just because the considerations for where to place the baggage is somewhat similar to where to place the fuel tank. So I've kind of lumped them together into one video. Now if you aren't familiar with this video series, the UWS-4 is an ultralight airplane that falls underneath the Federal Aviation Regulations of the United States, Part 103. And Part 103 restricts some of the aspects of the airplane. For example, the empty weight has to be less than 254 pounds, the stall speed has to be equal to or less than 24 knots, and the maximum level cruising speed can't be more than 55 knots. Those are the most significant restrictions that Part 103 places on our airplane. Now, let's get to it. Now, just a brief reminder of what we covered in the last video on the design of the UWS-4. In that case, we considered the overall or big picture parts of the structure. So, for example, that would be the spars, front and back spars, the major ribs that were going to have to be in there. Talk about the tail, so the skins and the major spar there, the booms, the shape of that, how we're going to attach it. Although that was modified a little bit in a follow-on video that wasn't a design video. It was a time-lapse video where I had to re-add the airplane into OpenVSP. OpenVSP is the program that we're using to help configure the airplane. And at the end of that video, I talked about a slight design change on the booms. And we also put the pod or the fuselage where the pilot sits and where the engine is, and the structure for holding the engine. And inside the pod and for the engine mount, we're talking about using a steel tube truss. And then a quick reminder about the book we're using to help guide us in this design. Like I said before, we're using Dan Raymer's book, Simplified Aircraft Design for Homebuilders. Now, Dan wrote this book for people who are designing sport airplanes, small airplanes, 1 or 2 or possibly even 4-seat airplanes that they would build at home. And so, as the title suggests, it's very simplified. It doesn't go into really deep math or really deep theory. It uses tables and some simplified equations to help design the airplane. Now we're using this to help design an ultralight. An ultralight's going to be slightly different. It's going to be much, much lighter. So some of the equations and some of the tables we had to modify just a little bit. For example, one thing that's going to be different is our payload, which is basically our pilot and fuel, is such a much larger percentage of the total gross weight of the airplane in comparison to a home built that's 1 or 2 or a 4-place airplane. So you've had to make a few modifications. And Dan also includes information on other configurations like canards. So if you're interested in designing your own airplane, I would recommend going ahead and getting Dan's book. It's a nice small book, it's not expensive, and there's going to be more information in there than you'll get from these videos that I'm doing, because I'm only taking the portions out of Dan's book that we need for our design. Now, if you'd like to get Dan's book, or at least learn a little more about it, there's a link down in the description that will take you to a webpage for the Ultralight Airplane Workshop's website. And there are going to be links to a number of books there that you can get at Amazon. Now, if you click on one of those links and buy while you're using that link, the Ultralight Airplane Workshop will get a small cut of those proceeds. Again, for you guys following along at home, we're going to be on page 63 of Dan's book, where we're talking about sticking in the fuel. Now, Dan mentions that airplanes that are home builders, typically the weight of the fuel is 10 to 20% of the gross takeoff weight. But what is it for ultralights? Well, Part 103 restricts ultralights to no more than 5 gallons of fuel. So let's calculate that out. So with 5 gallons of fuel at 6 pounds per gallon, and assuming a gross weight of 517 pounds, and that's what we have for the UWS-4, that's roughly 6% of our total weight. So we are significantly less than what Dan says is typical for a home-built airplane. So again, for our ultralights, that's something that's a little bit different than what Dan's assuming in his design criteria. But in this particular section of Dan's book, that difference between the percentage weight between an ultralight and a typical home built isn't really relevant. Well, now that we come to this page, I guess there is some relevance. If your fuel isn't located directly over the center of gravity of the airplane, as you burn your fuel, your center of gravity is going to move. So for ultralights, since it's a lower percentage of the total weight of the airplane, that change in center of gravity won't be quite as bad as it would for an equivalently placed fuel tank on a larger airplane like a home built. But it still can affect our CG. We in particular really don't want the CG to move aft of the farthest aft CG we're going to allow for the airplane. Now if we can, what's most desirable is placing that fuel tank as close to that CG as we can get. That way we don't have an unexpected shift in that CG while we're flying. Now another thing that Dan mentions is if that fuel tank is significantly below the height of the engine, you're going to require a fuel pump in order to get that fuel up to the engine. Typically the engine won't be able to suck the fuel a significant height. Now if you already have the fuel tank above the engine, let's say you have a high wing and your tanks are up in the wing and your engine is down fairly low, you may not need to have a fuel pump, or at least you don't necessarily have to have a strong fuel pump. So you might be able to save weight in your airplane if you can leave that fuel pump out. Just put that fuel tank up as high as you can. Now, although there's a section a little bit later in Dan's book covering safety, placing this fuel tank and how to deal with the fuel tank and the hoses between the tank and the engine, there's safety that comes in there that you need to think about. And here's the things that Dan talks about. Now, if you happen to have a crash, you'd really prefer not to have the pilot covered in fuel. Number one, it's just uncomfortable if you get it in your eyes. But number two, if for some reason, somehow you happen to have a spark, you really don't want to have your pilot catch on fire. You want to make sure fuel doesn't somehow get on a hot engine. Again, that can start a fire in your engine compartment. And you need some way to know how much fuel you have in your airplane. Now, of course, you can estimate it as you're flying. If you have fairly good knowledge of your fuel burn while you're climbing, how long you've climbed, how long you've cruised, what your fuel burn rate is while you're cruising, you could have a fairly good estimate of how much fuel you'll have remaining. But unfortunately, people make mistakes. So it really is best to have some way of measuring how much fuel you have in that tank, whether it's a sight gauge or some sort of electronic measurement. Because if you happen to be flying low and slow like we typically do in ultralights, you really don't want to run out of fuel if you don't have a good place to land. The program that we're going to use to put our fuel tank into our airplane is OpenVSP. Now it's not going to deal with gallons. Now our length unit is feet, so it's going to be in cubic feet. So let's convert gallons into cubic feet. So 5 gallons multiplied by this wonderful little number here, which is the number of cubic feet there is in a gallon, we end up with about 0.7 cubic feet. So we're going to need a volume of about 0.7, a little bit less than that, in order to hold 5 gallons of fuel. So what are the decisions that I've made on placing that tank on the UWS-4? Well, I want to have it as close to the CG as I can. And because of some of the design decisions I made on the airplane, I think that's going to be fairly easy. So in order to have it on the CG and have it as high as we can so we don't have to have a really strong fuel pump or electric fuel pump, it's going to end up being behind the pilot's head. So I'm going to have to give some thought on how to make sure that tank can't rupture during crash, or can't at least rupture during a survivable crash and cover the pilot in fuel, because that is kind of a bad place as far as having a tank rupture and covering the pilot in fuel. So I have to give that some consideration. So I also have some decisions on whether that tank's going to be integral. For example, if the tank were in the wing, we could have a wet wing where the wing itself acts as a tank. Or do I want to have the fuel tank be separate? So what I think I'm going to do is I'm going to make a separate tank, and I'm going to make it so that I can remove it from the airframe. I'm going to bolt it to our steel tubing truss frame of the pod. Now, what am I going to make that fuel tank out of? Well, it could be fiberglass, it could be aluminum. I haven't decided on that yet. So I'm going to push that decision off into the future. I could make it out of either one. I think either one of these decisions could result in a tank that could fracture during a crash. Fiberglass, of course, is able to crack and break, and aluminum also is able to crack and break. Although if the aluminum is annealed into a soft condition, I think it's probably less likely to crack and break, so that's something I'm going to have to look into. Well, I went ahead and made an initial attempt at what I think I might do for the fuel tank and where I'm going to place it in the airplane. Let's take a look at that. So here's OpenVSP and the fuselage, the pod that I've placed in OpenVSP. This is a view from the left side of the airplane, the port side. So here is where I was thinking of placing the tank. Now, unfortunately, one of the safety issues that Dan mentioned is trying to prevent the tank from splashing the pilot if you have an incident, a crash. Well, I've got it in just about the very worst place for that, because it is right behind the head of the pilot. So if I do put it here, I'm going to have to give some thought on how to protect the pilot from a ruptured tank from putting fuel on the pilot. But I do have one thing that's a good thing about this placement. It's as high as I can get it in the airplane. This is the highest point on the airplane. I'm still going to use a fuel pump in order to pump fuel to the engine because we're just about the same height as the engine. This is the engine right back in here. Now I do have this steel tube structure that I can bolt the tank to, so I can make sure that it at least can't come loose. I can weld tabs to these tubes, and I can make tabs in the structure of the tank so I can actually bolt it in quite a few locations. And by the way, this shape for the tank that I've done here, obviously this would have to be a custom tank. There aren't any pre-built tanks that actually meet these dimensions, but I came up with these dimensions so it would fit fairly snugly within this area on the airplane. Now, whether or not I can actually get it out, which is one of my goals, is a question that's open for debate. I think I will be able to unbolt it, slide it back and down into this area, and then turn it 90 degrees and pull it out to the top. Now, of course, I'd have to take some cowling off to do that, but I think it's possible that that will work. So one of the issues that is very possible that could occur on this airplane, particularly because it's a tail dragger, is that we could nose over, particularly if we had to land in a field of soybeans. Those are terrible. They like to grab onto the gear and flip your airplane over on its back. So if we do land on our back, we would be resting here. Now this highest location is in front of the CG, so we'll be resting on here and on our tail. Now, assuming that the tail booms don't bend, then the line that we'd be resting on would go back this way, so the fuel tank should be fairly protected from being ruptured from hitting the ground. In order to ensure that a little bit better, I'll probably drop this down just a little bit, about an inch or so. Now, if we hit hard enough, flip over hard enough, these booms will crack and break, and then we will be resting with the engine and this spot here on the airplane. Keeping that in mind, thinking about that, I lowered this back end of the tank down so that it'll be below that line. So again, the ground should not be able to impinge on the tank and cause it to rupture. So I did give some thought in order to prevent the tank from rupturing and spraying the pilot with fuel. Now, one of the other things that Dan mentioned is you don't want to get fuel up here in this area. One of the things we're going to do in order to deal with a possible fire from that, and we've talked about this in the past when we were talking about the structure of this pod, there's going to be a firewall right here made out of stainless steel that comes down right through here and then right on down here down to the wing area. So if we do get a fire, hopefully that'll prevent fire from coming forward. We will also have vents up here in the area to help keep the pilot cool that will actually also flow back through some small holes in the firewall and then some holes back here in the back edge of this cowling, and that should suck any flames or smoke out of the cabin and out the back. Another thing to think about is I don't want fuel pooling if we have a fuel leak. So any fuel leak that occurs back in this area is going to drip down, and you can see that this back edge comes to a V down here. This is kind of a V shape, and then it comes down into here. So I want to make sure that this area right down here in the bottom of this V is sealed so fuel can't continue flowing forward, and I'm going to have a little hole down here that fuel could then drip down and out and then onto the wing. So that'll keep fuel from running back forward into the cockpit. The spot where we'll pull fuel out of the tank will be right down in here. I've built this inclined structure here so that when we are descending, coming down, we can have a fairly good angle, and as long as there's still some fuel in the tank, I can come down at an angle about like this and still have a fairly good supply of fuel coming out of the tank. Now, if we go beyond that angle, let's say we're in a really steep side slip, we'll have to have some extra fuel in the tank in order to still get fuel out of it. Not a whole lot. We don't need a whole lot, but still need some. So I could make this a little steeper, but I really don't think it's necessary. Now, one of the things I could do to try to ensure safety a little bit more would be to actually cut the fuel tank off here and then extend it back a little bit. By the way, I did measure this. This is about 0.66 cubic feet, so this should be 5 gallons of volume. And again, construction material, I still haven't decided. I'm still thinking of maybe using soft aluminum and welding it up. And soft aluminum is less likely to fracture and break in a crash. It's more likely to just bend. And when I say soft aluminum, I mean an aluminum in the T0 condition. The specific alloy I'd use, I haven't decided yet, but it would have to be a fairly easily weldable alloy. But I could make it out of fiberglass too. But I'm a little more reluctant to use that just because fiberglass is more likely to fracture. Of course, there are other fabrics you could mix into the fiberglass to reduce that problem. For example, Integra could be used. For now, I am putting off the decision on what the actual material is going to be for the fuel tank. But at least I now have an idea of where to place it, how I'm going to put it in, how fuel will come out, whether or not I need a fuel pump, and whether or not I can actually remove it from the airplane to work on it if I need to. Now, the next thing I want to talk about is baggage and where to place the baggage area. Now, this is not one of the things that Dan talks about in this section of the book, but I wanted to place it here in this video because it has some of the same considerations that you would have for the fuel tank. And one of those things would be CG. Now, the weight of your baggage probably won't change during flight, but from flight to flight, the amount of baggage you may be hauling will change, and that will change your CG. So if you can get your baggage fairly close to the CG, that would be a great thing. And I need to save some weight. I could put a hard floor in a baggage area, but since we are already going to be pressed on weight, I think what I'm going to do instead is I'm going to use netting, both above and below the baggage, in order to hold it in place while we're flying. So this is a couple of good things, especially the netting on top, and especially where I'm going to place it. Netting should be very light. It might be a little bit springy, but it should be very light. And the good thing about having netting on top of your baggage is it's going to hold it in place. So kind of like not wanting to have the fuel cover your pilot in a crash, you don't want to have your baggage smashing a pilot in the head during a crash. So let's take a look at where I plan on placing the baggage. Again, here's a left view of our airplane. So where I'm thinking of having the baggage is this really light green area right here. It kind of looks like a little bit like a pillow. It's supposed to represent a net that's bulged up on top because there's some baggage in there, and it's bulged down on a little bit on the bottom because it's going to be held around these corners or around these four edges. And this is just a placement representation, not necessarily a size representation, because I expect I'll probably make it a little bit bigger. It'll be a little bit bigger wide to wide. It'll probably come back just a little bit more, but it is placed fairly close to the CG. The CG is going to be about 25% of the core to the wing, so there's 50%, so right about there's 25%. So it could be some of the baggage will be just a little bit after that, but not much. It'll be pretty close. So I should be able to go from no baggage up to a number of pounds, 20, 30 pounds of baggage if I need to. So I think that'll work out reasonably well. So another option would be to actually put a shelf in here, maybe a shelf that would rest about the same height as this, then come forward about to the seat. But I'm a little concerned that a shelf is going to add too much weight, at least compared to a net. So my initial idea is to use a net in here. And in fact, I could take the net out if I needed to. Another thing that I like about a net, as long as it's a fairly secured net, is that in the event of a crash, especially with this top net, if we should flip over or something like that, everything here in this netting should retain here. It shouldn't hit the pilot. Now, of course, this will have a little bit of flex to it, so I might want to move it aft, this front edge aft a little bit so that nothing inside can come and bulge out and possibly hit the back of the seat. But I don't think it's going to be too big an issue, but I'll probably have to do a little experimenting and see what I think about that, see if I need to move it back just a little bit more. That would put the bulk of the baggage back after the CG, but not very far. I think that'll still be fine. I'll go ahead and mention that there was one thing I had in here before in this presentation, in this video, and that was the parachute. I was going to talk about the placement of that and some of the thinking and conditions I wanted to have in there in order to put that parachute and where I placed it and why I placed it. But I decided to move that. I'm going to put it into the section where Dan talks about safety and seat belts. And since the parachute is really a safety device, I'll put it in with the seat belt section. Now, what's the next thing we're going to talk about? Well, we just finished Chapter 4, so we're going to move on to Chapter 5. And Dan has several sections in there in Chapter 5 talking about how to draw the outside of your airplane and make nice, smooth lines. And Dan's method's pretty good, particularly if you want to hand draw. But we're using OpenVSP for all of our drawing. So I'm going to talk about how you should be able to get something very similar to hand drawing using OpenVSP, and you'll just let it do the drawing. You just plug in some numbers. Now, if you like this video, think about subscribing to the channel if you haven't done that already. That really will help out the channel. And if you like this particular video, go ahead and hit that thumbs up down there in the description area for this video. If you want to be notified about any more of these design videos that we're doing for the UWS-4 and any other videos that we're putting out, click that little bell button and enable it for notifications. Well, that's it for this video. Thanks for watching. Until next time.